Good day, friends. So this is the last set of notes for you, topic 4, and this is graphing equations, okay? And so the focus today is that I can create a table of solutions to match an equation. I can graph a given equation on a coordinate plane, and then I can write an equation from a given function table, okay? So I've got my pencil. So let's go with this, okay? I'm going to move this out of the way because this cord is just going to be the death of me. Here we go. All right. So this is my I do. And see, I have a function table, and this is extending from the function tables that we have already done. And we're going to complete our function table, and then we're going to be graphing our ordered pairs. Okay. And we've already graphed ordered pairs, so we kind of have an idea. So my equation is y equals 4x. Remember, a coefficient variable next to each other, no operation symbol means multiply. So x is 0. So 4 times 0, so we're going to rewrite this. Y equals 4 times 0. Okay, well, anything times 0 is 0. And then my ordered pair is going to be 0, 0. Okay, so we'll highlight those little pairs so we can know what we are working with. Okay, 0, 0. Now I have y equals 4 times 1. So 4 times 1 is 4. My ordered pair is 1, 4. All right, just reminding ourselves that's our ordered pair. All right, and we're just going to keep going and substituting what my x is right here. So y equals 4 times 2. 4 times 2 is 8, and I have 2, 8. And then I have y equals 4 times 3. 4 times 3 is 12, so now I have 3, 12. Now I have y equals 4 times 4, and I have 4, 16. I have y equals 4 times 5, and I get 20. So I get 5, 20. And then I have y equals 4 times 6, which is 24, and my ordered pair is 6, 24. Okay, so I'm just going to highlight my x's and my y's all the way down, and then the ordered pairs to connect that relationship. Okay. Now in this case, our coordinate plane, as you can see, is super tiny. It has been labeled for us, so that's a good thing. I'm going to take a bite of my eggs. Okay. 0, 0. So remember, when we graph an ordered pair, just the same thing as the coordinate plane. We have created our ordered pairs. Starting at the origin, we're going to go over 1, up 4. Over 2, up 8. And as you can see, the creator of this graph made it really nice for us to have intersections where our points will fall. Very nice. Over 3, up 12. Over 4, up 16. Over 5, up 20. And then over 6, up 24. Okay. Just going to connect those. Boop, 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 boop. That's it. So, this next one, you can always use your calculator because now I have a fraction. I'm multiplying a fraction. So now I have y equals 2/5 times 0. Okay, we know anything times 0 is 0, so my first ordered pair is going to be 0, 0. Y equals 2/5 times 1, and we know anything times 1 is itself. So we're going to have 2/5, and so I have 1 comma 2/5, okay? And then I have y equals 2/5 times 2, okay? 4/5. And so I have 2 comma 4/5. And then I have y equals 2/5 times 3. And so I'm going to, new one, 2/5. And I'm putting this in my calculator, as you can as well. 2/5 times 3. I get 1 and 1/5. So 3 comma 1 and 1/5. And you see they did really, see over here on my graph, they set us up again for perfection. Y equals 2/5 times 4. So 2/5 times 4, 1 and 3/5. Ms. Collins, I'm seeing a pattern. Yes, yes, you may be seeing a pattern, but I want you to get into the habit of practicing on your calculator, because when it comes TCAP time, you cannot ask anyone how to use your calculator or help with it. I know. It's a surefire sinker, isn't it? Times 5. I get 2. So I get 5 comma 2. Okay? So we're going to go over here and we're going to graph. So I have my origin 0, 0. Then I have 1 comma 2/5. So over 1 up 2/5. And these are super tiny, I know. Next ordered pair, 2 comma 4/5. 3, and then 1 and 1/5. 4 and 1 and 3/5, and then 5 comma 2, okay? And then I would connect that line. Okay, now if you're not with us today, I encourage you, well, you have to do the you do by yourself, and you can bring that in to show me, okay? And then same thing right here. You need to do this you do by yourself. Pause for 1 second. Okay, so that's on you. Right here, this time we have to determine the equation from the table. Okay, so now we're going to write an equation from a table. And we created tables with the function tables, but now we're going to write an equation with a completed table. So whenever you write an equation that would be potentially graphed, it always has the potential to be graphed on a coordinate plane. It's going to be y equals, because y is our dependent variable and x is our independent variable, okay? And there are only 4 operations that could get us from an x to a y. And when we are increasing, because 6 is moving up to 30, we can only add or multiply, okay? So we could say 6 plus 24. Let's just play with that, right? Because again, we're playing with it. 6 plus 24. How did you get 24, Ms. Collins? Well, I subtracted. I did 30 minus 6, okay? And we could say 6 plus 24. So, again, playing with it, figuring this out, I have to add 24 to 7. Well, will I get the same thing, 7 plus 24? I would not. I would not get 35. So I know that it's not adding, okay? I know it's not subtracting or dividing because y is bigger. So if it's not adding, subtract, divide, it must be multiply. So how do I get from 6 to 30? Well, if I don't remember what to multiply by, I should divide. So let's try this. 30 divided by 6. Well, you get 5. So we're going to say 6 times 5, okay, is 30. Well, what's 7 times 5? It's 35. What's 8 times 5? It's 40. What's 9 times 5? It's 45. So x equals, or y equals, x times 5 every time. So we would say 5x. Y equals 5x. That's it. Okay, that's our equation. So let's look at this right here, my W. 5 to 11. Well, again, I see that I'm increasing, so I am not subtracting, I'm not dividing, but I'm increasing. So I have to add or multiply. So 5 to 11. Well, the difference is adding 6. But 7 plus 6 is not 15.4. So I know now that I'm multiplying. So y is going to equal something times x. Well, 5 and 11 are not compatible numbers, so I'm going to do 11 divided by 5. And I get 2.2. So let's just try that out. So 5 times 2.2, 7 times 2.2. Oh, that works too. So y equals 2.2x. And that's it. All right. At home, you should complete those on your own. Okay. Now we need to write an equation based on the word problem, complete a table using the equation to determine points on a coordinate plane, and then graph the information. So my problem says Marshall uses 9 ounces of shampoo for 15 washes. Assuming he continues at the same rate, write an equation that can be used for the situation. Determine the number of ounces of shampoo he will use for 24, 40, 65, and 75 washes, and graph the information on the coordinate plane. So I need to figure out what is the unit rate, meaning how much shampoo do I need for one wash. And so I have 9 ounces, and I'm going to divide that by 15 washes. So I'm just going to say 9 divided by 15 washes, okay? And I'm going to get 0.6, but which is also 2/3. Okay, so 2/3 of shampoo, 2/3 ounce per wash. So now I have 24 washes, and I'm going to say y equals 2/3 ounces times whatever washes I have. Okay, so I'm going to say 24 times 2/3. You can also put 0.06 if you want. And I need to put that into a. So y equals 14 and 2/5. So 40 times 2/3. I get 26 and 2/3. And that's supposed to be 2/3. Was that supposed to be 2/3? Let me go back and look at that. Are you all yelling at me? Maybe. Okay. 65 times 2/3. Oh, nope. 2/3. 43 and 1/3. So I'm going to come back and look at that real quick. 24 times 2/3. Oh. I messed that one up. Should have gotten 16 whole. No, I was right. It was 14 2/5. I messed that up. Okay. This one should be 24. This one should be 39. And then 75 times 3/5. You know why? Because I was putting in 2/3. 2/3 every time. And this should be 3/5. Excuse me. And I said that, but I didn't write it. So 75 times 3/5 is actually 45. So what this means is that for 40 washes, you will use 24 ounces of shampoo. Okay, so I'm going to graph. So now that I have this is my ordered pair now. 24, 14 and 2/5. 24. So as you can see, this is not perfect. I know, how rude. Over 40, up 24. Over 65, up 39. Over 75, up 45. There we go. And it's linear. So on your own, I'm going to have you practice on the we do and the you do. Okay. I want you to work, because there's only 2 more problems left, and I want you to practice doing this one on your own.